Okay, so here I just added a step. I just plugged in the numbers in. So we have 2f, f is 15 pounds, d is 10 feet, cosine 160 plus 2 times mg is the weight force, so it's given as 50 pounds, times the d, 10 feet, and the sine theta. And that theta is the angle. You can see up here in the triangle, it's the tilt angle. And that was sine 25, and divide by the mass, which is, as just found, 1.552 to 8 slug, and take the square root, and you are gonna get the velocity. And the answer for this one is 9.52 feet per second. And the way to get the feet per second is thinking about that kind of unit check. Pounds is what? It is mass times acceleration. In English unit, mass is slug. Acceleration is feet per second square. So when you write these for the pounds here and there, so you are gonna see that slugs are gonna go away and feet square per second square, and then take the square root of that, it gives you feet per second. And that is the answer for part A. And again, you can solve this using Newton's second law and the constant acceleration equations, and that's for part C, but you're gonna get the same answer that way. Next, part B is where when we ignore that applied force. Then is, again, what happened here is that applied force, if you look at the energy conservation, we have this term here. I'm gonna try to highlight that, because we had the force doing the work, right? And because it's cosine 160, it is negative. So we are really taking energy out of the system. If we don't have that F, we won't have the work done by F. That means we're not going to lose the energy, and it's going to go more towards the kinetic energy. And that should tell you that that's why the estimation is larger for part B and D than this value, 9.52 feet per second. So kind of rearranging our equation. I'm gonna start with blue. So part B, I want to start with writing the equation again. Energy conservation, let's make a habit of doing that. And then think about the terms which are zero. Since the reasons are the same, I'm not gonna write it again, but please write it down, make a habit, especially for the first time you're writing this for the problem, okay? Delta K and delta U are keeping them. That means the weight force, work done by the weight force, is already accounted for as delta U. The work done term is going to have only, so if we draw the, let's just do it here. If we draw the box again, there is weight force downward, and now the normal force only, right? And remember that it goes this direction, so that's kind of a displacement direction. And we also said that this is our x. So there's no more F, and the work term has only two pieces. Work done by weight force and work done by the normal force. We already know normal force does not do work, and we already explained why. N and D are perpendicular to each other, and this is already accounted for delta U, right? So this is gonna go to zero as well. We're not gonna we're not gonna keep that. This means the total work is gonna go to zero. So if I write the energy conservation equation again, delta K plus delta U equals to zero. There's nothing else left, as it shouldn't be, right? And once again, writing what delta K is and what delta U is. Equals to 0. We're adding those terms. And similarly, we are going to think about, can I simplify further? Initially, kinetic energy was 0. The same reason. That's why it's okay not to write Y, because we've already given those reasons. And final potential energy, I'm keeping the same axes. I'm still saying ground is 0 potential. So they're still applicable. What is kinetic final? 1/2 mv final square. Initial potential is mg y initial, that's equal to 0. To find the velocity, first off, we can cancel the mass this time because each term has mass. And then rearranging it, that gives us 2gy initial. And you're going to take this square root because you're also taking the square root of this side, right? These are going to go away. So V final is going to be root 2 gy initial. And once again, the same geometry. What is y initial? Let's just take a quick peek. Yes, right here. Y initial is d times sine theta. So let's go down and write that. And one more time, that when you plug the numbers in, you are going to get your results. 2 times 32.2 feet per second square. D is 10 feet. And once again, sine this theta is a tilt angle, so it's 25 degrees. And take the square root. Now you should get larger, and the value I have, quickly find it. It is 16.5 feet per second. Okay. Okay, so again, this can be also found using the second law and also the constant acceleration motion equations. But this is the way that I really want you to learn how to do by using energy conservation.